Welcome to one more session of Maths Standard 8, and we are discussing angle sum property for polygons. Now you know that what is angle sum property? It is for in case of triangle, it is sum of the measures of the all three angles of triangle. Okay, it is angle sum property for triangle. See, you know that sum of the measures of angles, three angles of a triangle is 180. Okay, you have learned in earlier classes. Okay, if you try to find out some of the measures, look at it. This is how you can find the measures. Okay, by setting the protector at any angle, you can find the measure of this angle, and by keeping here, you can find the measure of another angle, and by keeping here like this, setting it on an angle, you can find the measures of third angle. Okay, so this is how you can find the measures of all the three angles, and you come to the result that sum of the measures of all the three angles of a triangle is 180. Now, what about the sum of the measures of angles in case of a quadrilateral? Okay. Now, how to find, my friend? If you draw a diagonal, one of the diagonal, if you draw one of the diagonal, then this quadrilateral is divided into two triangles. Look at it. It's a 1, 2, 3, 4, 5, and 6. So two triangles, and their angles are noted as 1, 2, 3, and 4, 5, 6. Now you can see that it's a 1 plus 2 plus 3 is equal to 180, and it's 4 plus 5 plus 6 is equal to 180. Now think of A plus B plus C plus D. It's a sum of the measures of all the four angles of a quadrilateral. But look at it. A is it's sum of 1 and 6. Okay. Plus B is 2. Plus C is 3 and 4. And D is 5. So finally, it's 1 plus 2 plus 3 plus 4 plus 5 plus 6. It's a 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, so 1 plus 2 plus 3 is equal to 180, and 4 plus 5 plus 6. It's a sum of the measures of angle. It's also 180. So what we move to come to the figure of 360. Means what? Sum of the measures of angles of a quadrilateral is 360. Okay, very good. Now exercise 3.1, question number 1. Given here are some figures 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 figures given to us. Now we have to classify each of them on the basis of the following. So there are 5 bases given to here, and we have to classify it. Now keep one thing in mind that one figure can be classified in more than one criteria. Okay, so more than one criteria. A single figure can lie in more than one criteria. Okay. Now look at it. This is our look at the criteria. It's a simple curve, simple closed curve, polygon, convex polygon, and concave polygon. Now, my friend, it's a simple curve. So, if a figure can be drawn using a pen without lifting a pen, it's a curve. Without lifting a pen, it's a curve. Okay, it's a simple curve rather. If you can draw a figure without lifting your pen, it's a simple curve. And moreover, if the line do not cross each other, then it's a simple curve. This one is not a simple curve because here the some portion is crossed each other. Okay, so this is simple curve. This one is also simple curve because you can draw it without lifting your pen. Okay, now this one is not. If you want to draw two ovals, then you have to lift your pen. This one is not a simple curve because the lines are crossing each other. This one, okay, you can draw it without lifting your pen. So it's a simple curve. This one is also, and this one not. So there are 5 figures. It's a 1, it's 2, it's 5, then it is 6, then it is 7. Okay, very good. Now think of the second criteria as a simple closed curve. Now my friend, all these figures simple curve, and out of simple curve it can be closed curve or open curve. So these 5, this is simple curve and also simple closed curve. ये सिंपल क्लोज, ये ओपन कर्व है, लेकिन अगर उसको जोड़ दें तो ये क्लोज हो जाता है. ओके, सो दिस इज सिंपल क्लोज कर्व, दिस वन इज आल्सो सिंपल क्लोज कर्व, दिस वन इज नॉट द सिंपल वंस. ओके, दिस वन इज सिंपल क्लोज कर्व क्योंकि हर दोनों छोर से वो बंद है. दिस वन इज आल्सो एंड दिस वन इज आल्सो. सो इट्स वंस अगेन 1 2 5 6 and 7. All these simple curves, all the 5 are closed curves. Now third criteria is polygon. Now the figure formed by straight lines and closed figure, they are polygons. So this one and this one are polygons. So this one is not, no. So only 2 figures are polygons. It's a 1 and 2. And now these 2 are polygons. So polygons can be convex polygon or concave polygon. Now this one is now think of convex. This one is convex because which is convex and which is concave? Look at it. See, if you draw the diagonals and not a part of diagonal is out of the polygon, that's why this one is convex polygon. It's a figure number 2. But and this one is, look at it, if you draw the diagonal, okay, if you draw the diagonal, one of the diagonal, look at it, so some part of diagonal is out of the figure, and that's why this one is concave polygon. So first one is a concave polygon. This one is pentagon, and one diagonal of this figure is out of the figure, and that's why some part of the diagonal is outside the figure, outside the polygon, and that's why this one is concave polygon. Okay, my friend. Now, question number 2. How many diagonals does each of the following have? Okay. How many diagonals does each of the following have? Now we have 3 figures, and we have to find out the number of diagonals a particular figure is having. Now, what is diagonal? The diagonal is a line segment formed by joining two non-adjacent vertices. Okay, diagonal is a line segment formed by joining two non-adjacent vertices of a polygon. Now this one is a polygon. Okay, A, B, C and D. So if you join A to C, then AC line segment AC becomes a diagonal and BD is the other diagonal. Okay, so by joining two non-adjacent vertices of a polygon, you can draw a diagonal. So there are two diagonals. How many diagonals are there? Two diagonals. Two. Okay, number of diagonals is two. A convex quadrilateral can have two diagonals. Okay, now regular hexagon. Now you see that regular figure means what? Any polygon, regular polygon means what? Number of sides, all the sides are of same length and all the angles of same measurement. It's a regular figure. Now regular hexagon means hexagon having 6 sides and 6 angles. Now you can see that how many diagonals are there. Now let us try forming the diagonals, starting with A here, A, B, C, D, E and F. Look at it. So we have to join two non-adjacent vertices. So we cannot join A and B. We cannot join A and F. Okay. So this is the first one, AC, then AD, then AE. Okay. 3 from A. Now starting with B, it's a BD, then BE, then BF. So 3 from A, 3 from B. Now from C, C1 it is already there, CA. So from it's a C, not CA, then CF, then CE. Okay. Now 3 from C. Okay. Now it's 3 from A, 3 from B, 2 from C because CA was already there. So 3 and 3, 6 and 2, 8. And now think of D. As you can join DF because DB and BA already joined. Now from E, 3 is there. Now from F, 3 is there. Okay. So there are 9 diagonals we can draw. Okay, 9. How many diagonals we can draw? It's a 9. Now think of a triangle ABC. So you cannot draw a single diagonal to triangle because if you start drawing diagonals, forming diagonals from A, B and C both are adjacent vertices, and you you don't have any non-adjacent vertices from any vertices. Okay, so not a single, it's a 0 diagonals. You cannot draw a diagonal. Now my friend, there is a formula. Number of diagonals is equal to number of vertex minus 3 divided by 2. किसी भी पॉलीनॉमियल को जितने वर्टेक्स होते हैं फिर ब्रैकेट में नंबर ऑफ वर्टेक्स माइनस 3 डिवाइडेड बाय 2, ये नंबर ऑफ डायगोनल्स फाइंड करने का फॉर्मूला है. देखो हम क्वाड्रिलेटरल में सोचते हैं. सो क्वाड्रिलेटरल में कितने वर्टिसेस है? देयर आर 4 वर्टिसेस. हाउ मेनी वर्टिसेस आर देयर टू अ क्वाड्रिलेटरल? देयर आर 4 वर्टिसेस. So V is a number of vertices in a polygon. Okay. Now again, it's a V number of vertices minus 3. It's a 4 minus 3 divided by 2. It's a 4 into 1 divided by 2. 2 to the 4. It's a 2. us go for hexagon. Okay, hexagon. So number of vertices into number of vertices minus 3 upon 2. So how many vertices are there? A, B, C, D, E, F. There are 6 vertices. So 6 and 6 minus 3 upon 2. It's a 6 into 3 upon 2. 2 3s are 6 and now 3 3s are 9. Okay, how many vertices are, how many diagonals are there? There are 9 diagonals. And think of a triangle. Okay, triangle. So it's a number of vertices is 3. Then 3 minus 3 upon 2. It's a 3 into 0 divided by 2 is 0. So the number of diagonals to a triangle is 0. So without actually drawing the diagonals and counting it using this formula, you can find the number of diagonals to any particular polygon. Okay, very good, my friend. Now question number 3. What is the sum of the measures of the angles of a convex quadrilateral? Okay, just few minutes ago we have drawn a quadrilateral and we tried to find out some of the measures of the angles in a quadrilateral. Okay, will this property hold if the quadrilateral is non-convex? Okay, see, look at it. This one is a convex quadrilateral, and some of the measures of the angles of a convex quadrilateral is 360, my friend. Okay, 360. Sum of the measures of the angles of a quadrilateral is 360. Rather convex quadrilateral. Okay, now we have to find out, we have to verify whether this property, does this property hold when the quadrilateral is non-convex? See, look at it. It's a non-convex quadrilateral. This one is non-convex quadrilateral. Okay, some part of a diagonal, some part of any one diagonal is not completely inside the figure, inside the quadrilateral. This why this one is concave quadrilateral. Okay, non-convex, it's a concave. Now we have to see whether this property holds for this one or not. Okay, so for that, this is the figure and we will try to find out roughly. Okay, roughly we will find out. Now find out the measure of this angle. It is approximately 10, 20, 30, 40 and 41. Okay, now think of this. Okay, think of this quadrilateral. It's a 10, 20, 30 and 34. Okay, now think of this one. How much it is? So it's 10, 20, 30, 40, 50, 60, 70 and 80, and it's approximately 81. Now what's about this? What's about this angle? This is the angle having more than 180 degree. Okay, and for that we have to draw a line. So this is 180 and more. Look at it. How much of this angle? So this angle is having 180. Now we'll add this part. Okay. So this is having approximately 32. Now It's approximately 34. Here it is 34. Okay, 34. Now this angle is having 180 plus 34. 180 plus 34. It's at 212, 240 degrees. So this angle is of 240 degrees. Now it's an angle A plus angle B plus angle C plus angle D. How much it is? A is 81, B is 41, C is 214 and D is 34. Okay. 1 and 1 2, 2 and 4 6, 6 and 4 10. Remainder 1, 1 and 8 9, 9 and 3 12, 12 and 1 13, 13 and 3 16. Remainder 1 plus 2 is equal to 3. Yes, my friend. Some of the measures of the angles in case of non-convex triangle is also 360. So this property is correct for convex triangle and for non-convex triangle also. Okay, so we come to the point that some of the measures of the angles of a triangle, whether it is concave or not concave, whether it is convex or non-convex, some of the measures of the angles for a quadrilateral is always 360. Okay, very good, my friend. Now in question number 4, examine the table. So this is the table. There are 4 convex figures. This one is triangle, this one is quadrilateral, this one is pentagon, and this one is hexagon. Okay, so a triangle is having 3 sides, quadrilateral have 4 sides, pentagon have 5 sides, and hexagon have 6 sides. Now angle sum. Some of the angles of a polygon is known as angle sum property for that polygon. So angle sum property for triangle is 180. Means sum of the angles of a triangle is 180. Now what about quadrilateral? So there is having 4 sides. It is having 4 sides. So the number of sides minus 2. It is always minus 2. So 2 into 180 will be 360. Now how can we come to know 2? It's a number of sides minus 2. That is 2 into 180. So 2 into 180 is equal to 360. Is the angle sum property for quadrilateral. Now think of pentagon. It is having 5 sides. So number of sides minus 2. It is always minus 2. Number of sides minus 2. It's a 5 minus 2 is equal to 3 into 180. So 180 is a 540. Okay. So angle sum property for pentagon is 540. Now think of hexagon. Okay. Hexagon. It is having 6 sides. So always number of sides minus 2. Number of sides minus 2. 6 minus 2 is 4. And 4 into 180. 4 into 180. It's at 720. So sum of angle sum property for hexagon is 720. Means sum of the measures of all the 6 angles of a hexagon is 720. Now my friend, we have a question. We have a question number 4. Now if a polygon is having 7 sides, now what will be the angle sum property for the polygon having 7 sides? It will be number of sides minus 2 into 180. Okay, it's 5 into 180. It's 900. Okay, sum of the measures of the angle of a polygon having 7 sides is 900. Okay, now if what is some angle sum property for a polygon having 8 sides. So it is 8 minus 2 into 180. It is 6 into 180. 18 6 are 108 followed by 0. It's a 1080. Okay, and see, you can complete it by yourself. It's very easy. It's an angle sum property for the polygon having 10 sides. And for 9, n. If a polygon is having n number of sides, then angle sum property for that particular polygon is n minus 2 into 180. Okay, and this is the generalized form, rather a formula to find angle sum property for a polygon having n number of sides. Okay, very good.